Okay, next up, as our last speaker of day one in stage 2, I would like to introduce Alvin from the committee at Hong Kong Computer Society. Hello, Alvin. I think you're muted right now. Hello, Alvin, you are muted. Hello, Alvin. Can you please unmute yourself? Okay. I think we need to ask him to unmute. It's at the bottom of the page. You should see it on the left-hand side, next to camera. There's a.
Hello.
Okay, there you go. Thank you, Alvin. Thank you. Just wanted to confirm that you can hear me correctly.
Yep, nice to meet you. Nice to meet you, everyone.
Nice to meet you. And I think you are here to talk a little bit about attack API architecture. Is that right?
Yep.
Okay, perfect. Now I'll hand the mic over to you, and we can begin sharing. Thank you.
That's good. So thank you participate and listen interesting topic. My topic is attack API architecture. So I suppose everyone are very interested in the API and development on it, in the business function, and everything seems perfect. Definitely yes, but in case you are not catering carefully, it might have some problem. So as a hacker, we were happy to have a easy developers in the API architecture. So why you say that? Because API having attack happening every day, really every day. I randomly grabbed some news just a few days before, like 12th of August. I just grabbed some photos, and you will find everywhere. And then the severity is serious. Once we expose the API data, API access to public, and all the hackers can get the data easily and exploit and leak the customer's data or your company confidential data. So eventually it's a huge loss. So how serious is it? I would say it's every day happening, even today. I just grabbed this news today, just in this morning. Google Fi uncovers tools which is used by Iran hackers. They can steal the data from email account, from Gmail, Yahoo, or Outlook. They can steal it everywhere. So think about, it seems like easy. It's not an easy work. I will show how hackers work after in the later slide. But it is not that safe in the world. So what's the problem in the API security? It seems like a boring topic, but it's important, seriously. So go back to something is like repeating every day. It's like OWASP, API Security Top 10. It's a list of it. I suppose most of the people would know of it. What is the broken object? What is the broken authentication? But how it happened? Are there any interesting actions, or the hacker what will they do? Actually, they attack very focused. As a hacker, they will attack and pinpoint focus in the API architectures and some points. Say, for example, in the slide, you see some cloud platform. In the cloud platform, there's you just exposing the API access. Then whether they have an unsecured API keys over there, or repository or storage you can find on it. And then in the client side, are there any hard-coded credentials in the application? Or in some API side, what are the logics as source, as problem? I'll show you some interesting way the hacker can find it afterward. So look at the architecture. And every part, every components can be the target to be attacked. I give you some example. Hackers has a lot of ways to attack you. The first one is a list. I will go through not all of them. It's still a lot others. So I go with some. The first one is attacking the authentication. This is easy to understand, right? the password brute force attacks, and then just randomly to generate the password to attack you. Seems like impossible. We have a very long link and the password right this moment. It's not easy to be attacked. But you know what? Hackers have a dictionary. They understand what's the most favored password structure over there. Say, for example, a special day of day. Actually, all the days, whole years, every day will be tried, and your daughter, your son, your boyfriend, your girlfriend's birthday, or some special name, or some special gift, some special days, or places, is all being inside the dictionary, and all the hacker will try one by one. So everything, in case it's meaningful, could be a trial, could work for a trial, right, as a password. So in case you know the hacker knows you in person, or knows you, find your information in the website, it's easy to understand you a little bit more. For example, my personal information or some part information can be found in the LinkedIn, and then you find in LinkedIn, you guess what's the person's portfolio potentially to be your password, and put it into your dictionary to try to hack in your account. The account may be your email account, as I just showed you a news before. It's like today have a Google email have been hacked in Iran. It's happening every day, right? So brute force attack. Another part of my famous attacking approach is the OTP attacks. You know, all the website is convenience. In case you don't remember the password, then you have a forget password, and then you will receive OTP. And then OTP actually is generated from the server side, API side in backend, and it sends you a SMS. And then, but the OTP actually will be input into the API part. You see, I have a sample here. It's just an email, and then an OTP and a password. The password is a new password, right? I can generate or try and brute force the OTP and create my own password set. So think about that. Once they get it, they have this email, they can brute force successfully by this OTP, then the password is yours. It's no more yours. It's the hackers. So 4-digit number is easy to brute force. Honestly, it's just a few minutes. Honestly. So yeah, this is a way. And others is like a predictable tokens. It's like, okay, some people would think token is more so safe, right? You have a long length, just like the screen showing in the downstairs, in over there, and then token is long strings there, and then but actually the length is come from some original number, maybe a structure or sequential number structure. And think about, in case the token is generated by a sequential number, they potentially can fall back and guess this and generate another token and try whether they can get for authentication as well. So try to generate a false, fake token and try to log in as in your person. They don't need your password. They don't need your name, because they're trying to guess the token. So it's interesting, right? Because the token, in case they brute force your account and password, then maybe you can lock the account. But in case the hacker is trying to brute force the token, no way to put it off, because yeah, it's just a long time. And then you would think, it would take many years to try it. Yes, maybe, but at the same time, they can try it in this kind of attack by multiple accounts, multiple robots in the world away from your countries. So this is very interesting, very useful, and very common attack way, but you cannot avoid that. Fuzzing. What's fuzzing? Make it simple. It's like find the error or exception from your API. Say, for example, as I say before, and the hacker will try your password and your account based on your portfolio. So in case I am a hacker, I can understand you more detail, more information of your profile, then I will have more chance to try to brute force into the systems, right? Is quite reasonable guessing. And then fuzzing is about they push some non-reasonable make an exception inside the API, and then make an error, create error over there. And then I'm expecting they have an error exceptions message will return to me. Say, for example, I put some special character into a JSON, and then returning an error say, oh, SQL invalid syntax. So I know this JSON is going to put into the SQL directory. So eventually I will try SQL injection. This is a way to let me know this is a loophole, potentially a loophole. So I will try an error and think about is a lot of API inside your system. Maybe your platform will have 1,000 API over there. They have way to try every API at the same time, and then go into the details of all API and try force all kind of errors and exceptions over there. As long as they can get more exception and more errors, they understand your system more, they will find a loophole eventually. So the main point here is like, all around the world, actually people, the hackers, will find the errors or exception or and then create the loophole to find where is the loophole. For example, you are using a lot of this different kind of products, software vendor around the world, right? I'm not going to open the names over there. The famous database, the famous API platform, the famous cloud platform, whatever. So they must have some version have exposing some issues, can be vulnerable, can open to be hacked. So this kind of problem package of the version have been logged and recorded from the community inside hackers. So the hackers know which package or which versions of the database have problem, and I can go inside this package, this database in case, for example, you're using a MySQL, okay, or Oracle, whatever database type, and one of the version, a very small number of version, they have a loophole over there. And then I find you are using this one by this fuzzing technologies, techniques, and then I find it, I can get the package, get back, and then I focus on this loophole and the weakness on this version and attack it. So that's why people will try to understand your platform as much as possible, because in case you're lazy, you're maybe just using an outdated patch, you haven't patched the security patch fast enough, and then you find some system which is you're using in the SQL, in the platform, in the application server or whatever, then you'll be attacked and focus. So this is a technique in the fuzzing. And one more is like in case they have identify or find some way to log into your system, or can grab a very low level token, and then eventually the token, or they try to hack into the account. They try to get into the account is ID 1, 2, 3, 4 and boost force over there. It's an object level. Maybe they can touch something they are not supposed to open it. For example, I get a low level rise on this system, but eventually I can go inside to touch other system because what? Because a lazy administrator. They maybe are missing, not necessarily lazy. I understand corporates have more than maybe 1,000, some thousand components at least, and then just a few administrator. They have to update all the patch at the same time. It's not easy to manage it. But in the perspective from the perspective of hackers, they're happy on that because must have some components is outdated, and must have some right setting of an authorization setting is not right. So when people, hacker, can go inside this authorization level to attack, that means they can have they are authenticated, go inside the system already. But that doesn't mean they can touch or authorize to touch everything. So they go inside the platform and try to touch everything and find the weakness and the rights control. They can touch everything and find it, and then eventually they might have the rights to as a administration. They can touch all the log, and then eventually they can change it. They can read and change a lot of things. So this is a loophole. A hacker would do it. So read it is easy, but more function is more horrible. say, for example, this is an example I make it here. It's like I just grab an API, collect and retrieve. I get a data from here and just get the customer profile here. Okay, it's easy, right? Fine. It's just a money information, some simple information. But I get it. I just simply try my rights, what I can delete it. I just in this slide, you see in the right hand side, right lower hand side. Originally, I get it, and then I try to change the post to be delete, and then once I get a delete, I find it, I can process it, and this record is deleted. And why this happened? Because the right setting has problem. It's because the limitation of the program cannot be allowed to control in function level, but just the customers can touch it, then they can touch it, and eventually the customer can delete data without their proper authorization. So this is a easy way. Once they find this kind of functions leaking into the control. Okay, this is even worse. This is even worse. It's like once I have the rights, I can touch something I don't supposed to touch it. I have the rights, I don't supposed to execute it, and then I can have a mass change, mass update, maybe mass create a lot of administration account behind your scene, behind the administrator scene. They don't know it because they just create another set of administrator over there and then open the loophole, and then they don't need to hack again because they have the exact true rights, administrator rights, and then go inside the system. So this is a kind of mass assignment. I can change all the rights. You see it here. Example, take it here is I change myself as admin. I change my friends to admin. Or I just remove you. I don't like anyone inside system, or just come to not to be naughty, whatever they want, right? So this is very easy in case they have the authorization. Another kind is like also is a sample example is like I want to change the port price. Yeah, I get it. I get a port price I just get from the API, but at the same time, maybe I post a return over there. In case the program managed it or developed is not that proper, they just straight away to post back, and then maybe it will be updated. Why will happen like that? Because we have a lot of package and connecting from the database and exporting as an API. And those kind of easy and convenience API is supposed for providing those function features. You can just like get it in a get API request and post to update the API request and then directly update to the database. This is a kind of convenience function. Maybe some people will like it, but not necessarily. Injection. Injection is like a database injection, a SQL injection, and cross-site injection. Cross-site injection is like it's easy to understand. Somehow, in case you got a phishing email, you open it, and eventually you're happy, but actually behind your scene, your website maybe inject some scripts over there, just like here. Just a script have an alert pop up and just say you are in the cross-site scripting already, and then you don't know behind the scene, and a lot of other people just opened it like that. What's the purpose of here? It's maybe pop up something on inside some topics website, and then we direct those customers to somewhere or collect some login information. Maybe the pop up, maybe it's a login box, name, password, and then click. Once they click, the hacker will have the password. Once they have the password, they can do anything, right? Cross-site scripting, and okay, SQL, low SQL injection is easy to understand, right? Everyone knows SQL and understand SQL. But in case you have an isolated SQL command from the application or system, then we will have an injection over there. So a lot of problem, a lot of problem. Who is supposed responsible of this kind of problem? Application developer, security team, or API or integration team, whoever. Have an argument just also today. As a twister, they say have a fake account, someone internally to expose to say, hey, they have a problem. Why we should have a fix? But management say, hey, hidden it, just cover this problem. I don't do it, don't expose it. But I don't have fix. So it's always arguments like who do that, who do the loophole. I think developer have a responsibility to deliver quality code. But at the same time, architecture and the management also. Management, just like Trista, I'm not sure. They covered up the fake account or the hacking problem, and rather it's true. That's open to discuss, right? But from my perspective, they definitely have the responsibility. So if we look at that, covering management other than management application team and the development, they must have a cycle, look at API and look at the security testing and discover what's problem in the runtime, and then do the analysis and return to have a improvement again. So definitely application team should have this. And also always a problem is the app, mobile app. I don't know why. It's quite a lot of app will have a hardcode credential inside the app inside, and easy to be open. Some of the app will be better. They have a pin, but still possible to be decrypted to get the hardcode stuff inside. So application team, mobile app team, right? And how about security team? All the topics will have a security team, right? But I think it's only 80% of the application or the system will involve the security team, and 20% they don't know. They don't do it. Seems like 20% is not that large, but think about that. In case we have 1 million application in the world, then how many have problem? A lot, right? Some thousand, some 10,000, maybe. Just have a quick calculation, you will see the world is big for hackers to play around. So what can we do? When we think about hacker, before we think about the security, we apply security architecture because the hacker. Actually, it's not because we are too boring to apply a lot of complicated architecture, increase the size of the systems. So when we look at that, we should focus in multiple parts. The first is like in the API security testing, firstly, to discover unsecure APIs. That's definitely the most important part. And you don't invest in this activity, you open your door. I open the door, I have it, but I fix it. I got to fix it every day. And then in-app protection, in case you're doing app is mobile app first, and mobile app first, that means mobile app is the very famous target from hacker as well. And at the same time, the API level. API level is not easy to identify the behavior of hackers, honestly. But we have some tools to, based on AI and machine learning, to understand the behavior of the API calling pattern. It's super not easy to be identified, honestly. Say, for example, the brute force I just introduced quickly before, some minutes before, they can have a single attack from multiple countries, but actually is controlling from single hacker. The control that hacker remoting to those remoting box and to fire the attack, and slowly they're very patient to do each execution. Patience means they can fire each request once per day, once per hour. You are not able to recognize it by any kind of CDN by this frequency. So they can wait, maybe collect some information daily from this country and other requests from another country. Maybe you see some errors or some logs inside the system, but it's not easy to identify, honestly. So, big example. Mobile app, very famous. Now we're talking about Web 3.0, and Web, of course, is very famous. IoT devices in API architecture. It's like in this kind of API architecture, we have a web application firewall detection in the front end. Do you think it's enough? If your patch is always up to date, and then have an API gateway. Suppose you have an authentication API client over there, you will control token, and all attributes is well properly configure it. So, but as I have said, authentication can be attacked by multiple ways: your password, your token, your OTP, or even, right? And then just go inside. In case they can come inside the platform, those ingress controllers have to control the traffic between the microservices. Microservices between have a connection between. They supposed to trust connections. So think about that. Once the hacker can come inside the ingress controller, they might can touch each loop of the microservices. Hopefully it will say, right? Because actually we have a lot of patch we're fixing, but patch me if you can. Maybe hacker is faster, maybe sometimes the patch is faster. It's a chase, it's a competition. So this is a long way. It is an unlimited, unstopped competition between the protection and the hacker. And what we can do, let's do together, is very old school, but it's true, is to discover what's happening, analyze what is happening, and apply the security. Discovering is like we can do as much as possible the security attacks and try to apply the protection and also the access control. I love this diagram. It's a blocks, it's a building blocks. Check each building blocks whether is all good enough in the top standard already. So this can help you and help our colleagues to make a relatively safe. You know what? As I mentioned, hackers love to find those old package or old outdated systems and find those haven't been patched system leaking open the loophole. And then because it's easy, right? I just find, oh, this one is a very old Apache, and I can hack in is a log4j, and just go inside and then open everything. I can see the log and can see the password, and then I just as an admin and easy, right? I don't have to wait. I don't need the patience because it's open. So that's why we say is whether we are hardware enough to maintain all the patches and security patches up to date. So this is one of the points. This is I want to share. So make it simple. It's API. I just draw a loop here. Just incoming from left-hand side, my left-hand side, okay, and then outgoing in. Return the response from right-hand side. Once they have had 4 checkpoints, we can do a lot of things. Once the API income, they have a detection. Rather, this is API traffic is unusual. So install some box, some firewalls have intelligent to identify behavior, and then authentication, authorization, definitely super important. Whether we were hacked and attacked, as I mentioned before, and then once we are going to return, is some kind of a storage. It's like we are going to remove all kind of sensitive data. Zero trust space is super important in API response. Don't disclose it, and then eventually log or audit, store all kind of audit log. Audit logs will say whenever they have touching some kind of sensitive data or request of touching to touch the sensitive data, make a log and record it. Potentially you will spot out some interesting behavior. Actually, they are hacker from Iran. I don't know, right? So it's a quick recommendation. Just try to engage your API team together with the security team and picture the whole architecture and together spot all components and just don't miss it and think all the way. It's lobs out and the east west all around the security architecture. This will help you, but definitely it's not enough because hackers is improving as well. Trace it and it's a competition. All right, so hopefully your API is speeding and it's all good, but at the same time protect from hackers. Thank you very much. That's my sharing.
Thank you very much, Alvin. Unfortunately, we don't have any time for Q&A, so I simply want to thank you for your sharing and for your interesting presentation.
Yep, thank you.
Bye-bye.